together and formally introduce, even as you continue doing the assignment that you're already doing. So let me just hear a reaction to know whether people are alive, kicking. Good morning.
Good morning.
Good morning. At least I heard from one person, so that shows me we are okay. So welcome to this course, Web Security. My name is Nelson Ochen. From your names here, I don't know whether I've met you. A number of names are familiar to me. But maybe we've met either in the corridors if we've not met formally for any class together. So the name is there, Nelson Ochen. When we resume, I sit in the staff room next to finance. That is Shupavu staff room. When we eventually physically resume and meet. Good. So sorry, last week I was not able to come. I was not able to hold the class. I don't know if some of you came in and you missed me. If that is the case, then I'm sorry about that. We will see if we are able to recover lost time. Though the course is not very ambitious, a lot of the things that we are also going to be discussing in the web security, you have also met in other security courses like cryptography and network security. Because web security really is just part of just one aspect, one platform, one avenue through which you look at security, but it's generally just part of the other security courses that you've also met. So I will share the course outline when we meet next time, but I want to spend a bit of today just introducing the course Web Security, which you'll also see it in the course outline when I share it with you next time. So Web Security, that is our course, appearing as the second part of my title here, Introduction to Internet and Web Security. But in my introduction, I also want to look at, remind you of a few ideas about the internet. Because the web, like we know it, me and you, the web is just one part of one service. The many services that run in the internet, the web is just one of them. So we are not able to discuss properly what web security is if we do not know what the internet is. So internet and then the web is just one of the services that run on that internet. So as attackers are thinking of compromising your security, and with security again, you just isolate out the key elements of security, the key services of confidentiality, integrity, and availability. So as attackers are thinking of compromising that, the security of your web systems, they may even go through the network that web system runs on. So we want to spend a bit of time discussing and distinguishing between the internet and the web, so that then thereafter we know what we are dealing with when we are talking about web security. Clearing that. So the internet, this is a review. So I'm not saying here that you don't know these things, but sometimes also it's good to remind ourselves to give us a foundation upon which you're able to build on the concept that you want to discuss. So here is a definition of the internet that I picked from Wikipedia. The internet is a worldwide public accessible network of interconnected computer networks that transmit data by packet switching. So it's global, it's worldwide, it's publicly accessible, because this normally allows us then to differentiate between the internet and intranet or extranet. So it's publicly accessible. A number of keywords we are able to identify here. It permeates the whole globe. It's publicly accessible, so differentiated from intranets, for example, that are accessible only within the confines of a particular organization. Is publicly accessible. Here is a network of interconnected computer networks. So we have a number of computer networks that are that are interconnected among themselves, and they transmit information, transmit data by packet switching. So the packet switching, that's a technology. Remember, we always differentiate between packet switching and circuit switching. So that was a conscious design by the designers of the internet to have it transmit data through packet switching. Remember, so that if particular sections of the network are destroyed, there's redundancy. Packets are able to reroute variously and still arrive at their destination, even if particular routes have been affected by some problem. So that's the definition of the internet. Remember, here we have just talked about it being an infrastructure. So no service yet. It's just a highway, a railway line, and in that highway, in that roadway, we'll then have services running inside there. So at that, this first slide, we are looking at the internet just as some infrastructure that then allows us to run particular applications. So what are those applications for those cars, those automobiles that can run on that, that can go through that infrastructure? So a number have been listed here. We have emails, email as a service that the internet provides. And of course, when we normally talk about this email as a service that is provided in the internet, we are more often thinking about the email where we have an email client and an email server, not web-based email. Web-based email will then be considered under www. Web-based email like Gmail or Hotmail will be under the second service here. So email is one service provided by the internet. We are not in this course going to talk about email security. www, which is the World Wide Web or the web, whose security is what we are going to be concentrating on in this course. So in this course, we are concentrating about the security of the web, not security of email, for example, or security of FTP, or security of remote access, or VPN security, or IRC, or instant messaging security, or streaming video, or VoIP security. These are other services that also run on the web, but with security is not going to be key to us here. So our focus then is just on this service. But because this service runs on the internet, me and you agree that it can still be compromised by compromising the internet generally at the level of even the packets, the IP packets that they traverse the network. You are still able to affect the security of the web. And that's why it's important to get that background. Good. So we, in this particular slide, also give a definition of intranets. So I'm sure in the applications that we've been developing, some of you have been developing internet applications, some have been developing intranet applications, and probably some have been developing extranet applications. Some have also been developing mobile applications that interface with web systems. So really, this course touches also on just a bit on the security of web mobile apps, but just insofar as they are interacting with web interfaces. And they have a backend which interacts with the web interface. So the intranet here has been defined now as a private computer network, different from the internet that was a public computer network. It still uses the same technologies that the internet uses the internet protocols. I'm sure you know about these protocols, for example, the TCP/IP protocol suite. So uses the internet protocols and network connectivity to securely share part of an organization's information or operations with its employees. So is a situation where an organization particular resources, they want to be able to share these resources with the employees and the employees may be located somewhere else, which is not where the organization is located. They may be sitting at home, for example, like we are doing here today, and the staff wants to share some resources just with us, not with everybody in the internet. So because of that, we create an internet that allows us to share this information. In bullet 2, saying normally intranets are connected to the internet through a gateway with firewall to increase security. So the firewall will allow you to block particular traffic that you don't want to either leave the organization or come into the organization. Good, so that's the intranet for us. Then we have the X now, which is also still a private network, still using the same technologies that the internet uses, and possibly also the public telecommunication system, which probably uses a switched circuits instead of packet circuits to securely share part of an organization's information or operations with not the employees now this time alone, but with suppliers, with vendors, with partners, and with customers. So if you're able to develop an application that can allow organization to share information for its operations with other stakeholders, like the people who supply, then that's an extra. So we have those three different categories: the internet, the intranet, and the extranet that we normally develop applications for, the applications of which we want to support security. The applications with security we want to support. Good, so some history here, some history of the origin of the internet, starting as ARPANET in 1969. Of course, the name coined from the funders, the original funders, which was the Advanced Research Projects Agency, an agency of the U.S. Department of Defense, Advanced Research Projects Agency, ARPA, and creating that initial connection of computers that was in those days called ARPANET in 1969. Really not a very old project. The original idea was to design it for researchers to communicate and share information with each other using disparate physical networks. So different researchers hosted in particular universities using different using networks supported by different vendors. They wanted to share information, and ARPANET came in to meet this need to allow these researchers seated in different research institutions and universities to search information. In that particular time, then it was confined to research communities. Where it is now, courtesy of internet getting into the business world, balloon, and it's now covering the whole world, not confined to just research universities. The goal of the internet, the goal of connecting those computers, those computer networks, of course, in addition to allow these researchers to share information, the original designers designed it in such a way that it was able to survive an attack, a nuclear attack. Nuclear attacks were then a big deal. And the design decisions were made in such a way that you came up with a network that was a nuclear attack, destroying particular sections of the world. And because of that, you remember we talked about packet switching that allows your packets to reroute to use other routes to arrive at the destination. Now, in that time, then the internet was rudimentary. Now, come 1989, this gentleman, Tim Berners-Lee, invents HTML. So previously, then we don't have HTML, and because of that, the internet doesn't grow as much as after HTML comes. So Tim Berners-Lee He was in Kenya a few years ago. Tim Berners-Lee invents HTML, and with this, the rapid growth of the internet, fairly recent, when I was in class 8. Don't know where you guys were. So which means then for me, I could not have discussed these things previously because they were not invented. So a bit of the origin of the historical discussion, the origin of the internet. Now let's then narrow down to our focus, which is this particular service, www, or World Wide Web. And we give you a definition that differentiates it from the internet then. So www, or the web, is here defined as a system of interconnected hypertext documents. Really, we change this subsequently, not to hypertext, but to hypermedia. I think we better change here to hypermedia, because it's not only text that we are changing. This should be hypermedia. So text, so document, videos, sound, images. System of interconnected hypermedia documents accessed via the internet. So there are resources which are connected. We normally navigate from one resource to another using hyperlinks. So it provides a linear navigational experience, different from reading a book that we have to start from there and we read through to the bottom. With the web experience, is not linear. We are able to jump from one resource to another resource and back using hyperlinks. So if we have a system of interconnected hypermedia resources that we access over the internet, then that's what we are calling the web. It uses this as a key protocol, HTTP, Hypertext Transfer Protocol. That is going to be the key protocol whose flaws are going to lead to breaches, and which we are also able to harden to ensure that we protect ourselves against a number of breaches. So the key protocol that the web uses to transfer these resources is Hypertext Transfer Protocol, HTTP. But the protocol that is used to mark up or annotate resources so that the web browser can interpret them correctly is HTML.
10:15.
So HTML, remember, from your discussions of web development, is allows you to mark up or annotate your resources to assist browsers, web browsers, to be able to render or display them appropriately. So HTML for markup and HTTP as a protocol that allows web browsers, for example, to communicate with web servers, because then they'll be talking a language that they both understand. So how does the web work? How does the web work? It's easy to take this for granted, but let's see how it works, review how it works. So typically, a user types the URL of a web page in the web browser address bar. If you want to go to a particular web page, for example, if you want to go to stratmo.edu, then you're expected to type in the URL www.stratmo.edu in the web browser. Alternatively, you have clicked on a particular hyperlink in a refer a document to page browsing, and then you saw a link there which leads you, when you click on the Stratmo website. So typically, user types the URL of the web page in the web browser. A link, that's what normally happens first. Then the next thing is the server name URL. In our case, if we are going to http://www.stratmo.edu is what we are talking about there. The server name part of the URL into an IP address. So remember, computers will not be able to route any traffic to stratmo.edu as an English name. It must be resolved to something that the web browser and the web server understand. So it's solved into an IP address, 192.168, for example, .170.15, an IP address by the Global Distributed Internet Database, known as the DNS, the domain name system. The Global Distributed Database, DNS, allows name resolution. At the end of this presentation, I'm asking you also to do to prepare some write-up on the DNS, which is the Global Distributed Database that allows us to resolve a domain name to corresponding IP addresses. So once that has happened, then the browser now knows who to compete with. So the browser then establishes a TCP connection to that IP address, resolved in step 2. Web browser establishes a TCP connection with the server at that IP address. So remember the TCP connection, three-way handshake. The TCP connections created through the TCP three-way handshake. You are able to remember that from your networking. So the browser establishes that connection. So once the connection has been created, let me just submit someone here. Once the connection has been created, an HTTP request is sent to the web server located at that IP address that a connection is made to. An HTTP request is sent to the web server. Now that HTTP request will obey a particular format. So we have an HTTP request format, and similarly, we also have an HTTP response format. If it's not coming in the subsequent slides, I will ask you to review the HTTP request format and HTTP response formats. So that request, of course, is to obtain a resource, maybe from the web server located at a path that you're going to, and that resource is retrieved and returned to the web browser. And the web browser can now render or display the page as it has been described by the HTML, the markup there, the cascading styles, the images, the video that are in that document. So in a nutshell, that's how this web that you want to secure works. We have to understand it before we can secure it. So that's the way it works generally. So some key internet concepts here, design decisions. So the internet has been structured as an open architecture. It's not a closed system. It allows us to extend, because with the open architecture comes extensibility. We are able to extend with plugins, for example. We are able to mix disparate vendors. So it's not that belong to just one vendor. So we are able to put in a browser from Microsoft, a plugin from a different Flash player from a different organization. We can run online apps, we can run on PCs or MacBooks. So it's not a closed system. That's, I think, a good thing, but also a bad thing, especially in terms of security, because now you have vendors. Now, the internet is also based or using packet switching. If you've forgotten this, remember this is a situation where there's no dedicated communication channel, and information that is to be routed, be it email or files, is first divided into blocks that are called packets, and these packets are sequenced. These packets have a source IP address, and they know where they are going, the destination IP address, and they can travel each packet using whatever route is convenient to it. And when they arrive at the destination, they are reassembled according to the sequences. And particular packets that don't arrive, the receiving party can ask for retransmission, and so that they can be retransmitted. The internet is also used the protocol suite. I hope you're able to work closely with the TCP/IP protocol suite, the different layers of that protocol suite and the different protocols that are in those layers. For example, now HTTP at the application layer of the TCP/IP protocol suite. But then below it, you have other protocols which are supporting networking, supporting transport, and supporting or the data link or physical layer. So be very conversant with those layers. There's nothing to prevent me from asking you to, in an assessment, to describe what happens in a particular layer. The internet is also based on a client-server architecture. So you're able to summarize the internet by just saying that particular devices are clients requesting for resources from servers. So clients requesting for resources from servers. So we have an email client and an email server. We have a web client, for example, a web browser, an HTTP, a web browser, and we have a server. So all things written just obey that. There's a client requesting for resources from servers who provide resources. And if you are going to look at security for any of those services, then you'll be looking at the security of the client, you'll be looking at the security of the server, and the security in the intermediating medium here, the network. Now let's then continue to narrow down our discussion from that general discussion of the internet to now looking at web security, which is what the course is about. So web security landscape. So the different facets of web security have been isolated out here. Remember, there's a web server, there's a web browser, and there's a communication channel between the web browser and the web server. That's the internet. So if you are going to secure the web applications, remember one of the motivations which you see in the course outline for this course is to allow you to develop secure coding practices as you develop your web and mobile applications that interface with the web. So if you are going to secure the web, then you need to secure the web server and the data that resides in that web server. You also need to secure the browser and the device that hosts the browser. And you also need to secure the channel between the browser and the web server. Those are the different places where you need to put in your effort as you talk about, as you implement web security. So what do attackers care about? So we know we are going to provide this security against attackers. So what do attackers care about? In the assignment that you started with doing and that you're going to continue to finish up on and present, you've been talking about these kind of things that are put down here. And there are things that attackers care about, the things that the attackers care about. So data breaches for financial gain. So if attackers are able to get data, filtrate, get in and get data, what we are calling here data breaches, they're able to use that for financial gain. How so? Through extortion. We have data that we are able to now, almost force you to pay us. Otherwise, we are going to leak it. So through extortion, they can also sell it in the black data market. They can sell particular data. Ransomware attacks, encrypt, for example, the information that you have, your final year project when you are just about to present. And once we've, I think that's the one. Yes, once you cannot open it, then we ask you to pay us money before we are able to release it back to you encrypted. So for financial gain, attackers may also care about just the ability to execute commands on your hardware for some reason. For some reason, they want to be able to execute particular commands on your hardware once they have been able to attack your web system. Take control of your server and enlist it in a botnet. Attackers want to attack a particular service somewhere. They need computing power to do that. And of course, they also need to hide their tracks. They are able to take your machine and list it as part of an attack that they are able to they are able to route their attack to the service that they want to attack through. So they enlist yours and another person's and another person's, and have your computers now send a lot of traffic to the service, for example, that they want to deny, they want to have as part of a denial of service attack, for example. So now many computers send bogus traffic to some service that they want to compromise through a denial of service attack, for example. Attackers may also want to use your web server launchpad to now launch an attack to another computer. It may be related to the previous goal, but can also, instead of even listing computers in a botnet, they can just be using yours, your particular server alone, to disguise their origin, the identity, so that if there's a trace, the trace only comes to your web server as the initiator of some attack for some other web service. So those are some things the attackers care about, and which we want to be careful to protect. So some key security goals, really, for any security study, web security include some key security goals. Some people may also call them key security services. Sometimes these are also acronyms CIA, the CIA triad here: confidentiality, integrity, and availability, the CIA triad. Confidentiality. So you want information that you are transmitting to only be available to people who are authorized to access it. Information transmitted and available only to people who are authorized, to parties or subjects that are authorized to access it, and not to anybody else. Integrity. You want any modification of your resources, of your information, only to be done by people who are authorized in ways that are also authorized to do the modification. Availability. You want your systems or your resources to be able to legitimate requests as per the service level agreement. I was about to say always, but may not necessarily. You want the system to be available the way it was intended. If it was intended to be available 24/7, so be it. Of course, specific service level agreement that was there between the developer and the owners of the system. So those are some key security goals, and really these are what attackers normally want to compromise: confidentiality of resources, integrity of resources, and the availability of resources. Integrity of resources, for example, can be compromised by malware that can modify your resources even though you've not authorized them. Malware, malicious software, for example, computer viruses or computer worms or trojans, they can interfere with integrity. Availability, a possible attack is denial of service attacks, for example, distributed denial of service attacks that can compromise availability of resources. Confidentiality, password thefts, password leaks. If somebody is able to get to the password, a database or password file, and run it through a password cracker, retrieve the passwords, and use that to now get into your systems, of course, confidentiality would have been affected. So those are key security goals, and that we are going to be trying to protect ourselves from, protect our web systems from being compromised against. Now, some browser security concepts. Remember, we are going to secure the browser, secure the network, and secure the web server. So there are some few key browser security concepts that come in handy. One is this concept of the URL. we are going to be seeing the way this impacts on the same origin policy and in many other discussions of web security that we are going to be discussing. So here I've just reminded you about the composition of the URL. So here we have some URL, uniform resource locator, and the different parts have been isolated out here. Be sure to identify the scheme, the HTTP, identity scheme, the scheme. Then we have the host, then we have the port, port 80, yeah. We have the host, the scheme, then the path where the resource is located. Then after a question mark, name variable value pairs, query, call the query, and then the fragment. So in the path test, we are looking for the resource named by reference by color, and the particular resource is blue. And in that particular page, we want to go to this section 2. So that your whole page, once you get that resource, your whole page, and the fragment will indicate to you the section in that page that you need to jump to. Schemes are different. We have SMS, we have MMS, we have different schemes. This is just a computer that is hosting the resource, and then the port is where the web server is listening. Web servers listen at particular ports, port 80, majorly for web server, and there's a path to the resource that you want to retrieve. Then a query, which normally consists of a variable and a value pair, and then the fragment to refer to the section in that resource that you want to jump to. So what we call as the origin in that URL is this composed of the scheme, the host, and the port. That's what we are going to be calling the origin. And we are saying here, most security decisions made by the browser. Browsers make security decisions. Most of those security decisions that they make normally rely on that origin, on the scheme, the host, and the port. So there is some concept here called same origin policy or SOP. Contexts from the same origin can freely interact with each other, while something same origin then, remember, refers to the scheme, the host, and the port. So if any browsing context, you are going to be browsing, we see when we still look at cross-site scripting, that vulnerability or that attack, that it comes as a result of browsing from one website to another. Then you visit a site which is very popular, and that site introduces some JavaScript that you are going to carry ports to a different other website that you go to. So context from the same browsing context. What do you mean by context? Is browsing context, browsing experience. So browsing context from the same origin can freely interact with each other, while browsers would isolate and consider as insecure contexts which are not from the same origin, where the origin is composed of the scheme, host, port. So cookies are also an element that normally comes in. It's useful when we are talking about web security. I've just reviewed what cookies are here for those who may have forgotten from their web development units. A bit of information that the server can give to a client, and on every subsequent request that a browser makes to the server, the browser or the client will give that information back to the server, thus identifying itself to the server. It's used normally as a problem. Some browsers don't support cookies. The other challenge is users may also disable cookies. So if we rely on them, for example, to maintain state for our web applications, then for users who have disabled cookies, then we have a problem. But really, even for other session management techniques that web developers like you are normally use, a number rely on cookies to even store the session identifier. So you can read more about cookies there. It's something you know, and I don't want to spend a lot of time boring you with that. You're able to do that. So that presentation on introduction from my end stops there with an assignment here, which can also move. All our assignments really are going to be done in groups. So I want stop here with this assignment that we are going to add with the other assignment that you've started working. In your various groups, again, the same group, maintain the same group to the end. I want you to prepare some summarized write-up on the domain name system. Remember, this is a system that allowed us to resolve domain names to corresponding IP addresses that we mentioned when we were talking about how the web works. In various groups, prepare a short write-up. You are not going to present this. You submit through e-learning. Just a summarized presentation on how the domain name system works, how the DNS works, the concept of name servers, and the root and top level name servers. There's a short write-up in your group there that you will see in the e-learning that I want to point you to where to submit it before we meet next time. So 2 assignments. This is to be uploaded on the e-learning. I want to take you there to the e-learning. And the other assignment to upload in the e-learning. The other assignment you are not uploading, you will present when you should have presented it today, but now I want to give you just a bit more time. It's a short presentation of 3 minutes, 3 to 5 minutes on the key issues that you've noticed in the URLs that you've read. So 2 assignments. This is assignment number 1. I hope you understood what I want there. This is just an activity. This other one just an activity. You are not presenting or uploading anything. You can just go to that website. There's some service there, some web service there that allows you to see the communication between a browser and a web server, and particularly look at the headers, the different headers in the HTTP request and the HTTP response. So that's just an activity that to see by yourself. But what you're uploading in the e-learning is this one, domain system in the group. So just one upload in the group. Then the other assignment is what I have in the chat here. Just go to the chat. Not clear this. So in the chat here, I've said something here. I gave a number of URLs. Let me just remind those who came in late, as I also talk about that idea of coming late. So there are those URLs. There are how many? 1, 2, 4, 5, 6, 7. There are only 7 topics, which means some people are definitely then repeating some. But it's important. So people are indicating here. Those who came in from the beginning were indicating topics that they were working on. But because there are only 7, and I've seen you are so many. So those will be instead of people repeating, maybe I could give today. We can have some 7 groups working on this. Then the other groups that don't get what to work on, I will give them next time, next week, what to work on. So maybe we can just have the the people that picked these ones first to work on them, so that we are not repeating. There are only 7, and I think you're around 20 groups. So the rest, I will give them what to work on next time. So I can say, let me just pick a few here. There was a group by who? The person who started was called, those people who started. I'm sure there is no harm. Can we just pick again? I can't get to who picked first. Who picked MongoDB? Just once you type, I will see, and everybody doesn't pick. So just type yours, and then the rest who will not have typed. The first 7. Once somebody types, you don't pick theirs. So I've seen. So we just see the first 7 in the chat. So then we know who are working on this. Then we'll give the others next time. There's no problem. These are just things to give you marks. They are no difficult things. So I've seen MongoDB picked by Amani. I'll just write here the people we expect to present. It's just a short presentation with really no big deal, just itching to give you marks for doing very little. So Amani is on MongoDB. Then we have, so sorry, Vanessa, it's they wrote their name first, sorry. Caesar, I think even previously you had been the first one. So Caesar are working on how security flaws work, SQL injection. So you will just start looking at it there, but it's a topic that we'll dwell on at length later. So just give a very summarized presentation, 3 to 5 minutes. Just the key things I sold out in that case, not exhaustively, because we look at that topic again later. Consider that how security flaws work. This is a very high level. Don't go into details. We will do that later. So sorry. So that's Caesar. Then if you want to stop big data breaches, start with databases, that goes to Miriam Boga. Miriam, data breaches, start with databases. Then we have SQL injection, hall of shame. SQL injection, hall of shame goes to Anthony. SQL, hall of shame. Then we have how I compromised 4 locked Instagram accounts, Jessica and Rebecca. Rebecca's group is Instagram accounts. So we still have MongoDB, how SQL injection works, data breaches, still have 2 more. I've seen cross-site scripting, WordPress is by group. exercise, but do this. So we have one more. 1, 2, 3, 4, 5, 6. I think we have one more left there. Oh no, maybe I repeated one. No, one was repeated. So let those 6 work there. The others will give you, and you learn your marks next time. Now, before I also allow you to ask your questions, I want to talk about joining time. I'm seeing Joshua Mumani is joining now. Quite a number also joined in very late, and I kept on going to admit them from the waiting room every now and then. Like now, I'm admitting Joshua just now. So let's say next time, during our next class, I'll admit you in the first 15 minutes. So if you have a problem with your power, uh, your work, so sort it out. So I'll admit you in the first 15 minutes, unless, of course, there's a very good reason why you want to be admitted, like now. Somebody is being admitted at 10:50. The class started at 9:15, so 2 hours later on. So unless you have, of course, if you have a good reason, I'll admit you in time. But if you don't have a good reason, please try to be admitted in 15 in the window of 15 minutes, so that you don't asking me, you can't say something in the chat that I said in the beginning. So 15 minutes, I'll meet. After that, I will not, unless you have a good reason. That's fair, please, Chaba. That's very fair. So if something happens in between class and you're disconnected, I'll admit you. That's okay. But I will not admit you if you are just coming in now. And that's very fair. I'm the one to determine what's fair. So 15 minutes, that's fair. But of course, if in the middle of class you lose your connection and you want to come back, I will admit you, no problem about that. But when you're joining in for the first time, like someone joining now, I think that's not fair as well. Good. So that is it like that. There is nothing to agree upon there. I'll just dictate. So 15 minutes, that's my window to admit you, not open to any discussion. So let me then tell you these are presentations I want to anyway. Somebody, Derek, is still saying it's not fair. Okay, it's not fair, but that's my rule. So I'm the one to determine it. So I don't know what you can do about it. I doubt whether there's anything. Good. So that is it like that. Let me then allow you to ask any question related to the class. You can unmute if you want to ask a question. You can now unmute. Thanks for the discipline. You muted. We were not disturbed by background noise, which is commendable. So please keep up muting. So, but if now you want to ask a question, you can unmute and ask. I was taking you to the enrollment key. That's let me do that. So in the e-learning, if you go to the e-learning, there we have our e-learning. Let me just go. So I always just search. I don't know how you go there. So web security. I'm just going to the search box and search web security. There is a number of web security items. Look for the one with my name. I think it is ICS 4202. ICS 4202 with the name Nelson Ochieng. There. ICS 4202. And if you go in there, Even the introduction slides are already there. The enrollment key, let me just get it for you. The enrollment key is ICS 4202. Enrollment key ICS 4202. Let me just put it here in chat. Web security by Nelson Chen. Key is ICS 4202. Good. Checking attendance. I do want you to start writing your names here. Yeah, I'm seeing 105, 101, 057, Onyango Victor. Yeah, maybe you can also put it here. You can put your names there in the chat. But I'll also occasionally be calling people at random and giving some assignments at random during class, just to give sometimes mark for attendance. So if you're not there, you miss it. So the first 30 minutes we'll meet next. Amani, Caesar, Miriam, Anthony, Rebecca, and Julie's group to prepare to present. So it prepares PowerPoint presentation, maximum 5 minutes, just to talk about the breach that you found in the case that you picked. Okay, see you next time.